we looked at the length contraction and time dilation from the perspective of the space-time diagram. Let's now look at them from the Lorentz transformations. So we want a time difference delta t bar, t, which is t2 bar minus t1 bar. These are the coordinate values of times in the x bar t bar frame. This, by the Lorentz transformations, is t2 minus v x2 minus t1 minus v x1, all of this divided by 1 minus v squared square root. Now, if x2 is equal to x1, which means that the clock is at rest in xt, then what we have is t2 bar minus t1 bar is equal to t2 minus t1 over 1 minus v squared square root. So the interval of time, t2 minus t1, is related to that same interval, t2 bar minus t1 bar, by this factor. So this is greater than this, time is dilated. That's the time dilation factor. Right, so a 1 second on one clock, this tick represents, say, 1 second, and the relationship between them is this. That's the time dilation factor. Let's consider a length. So we measure a length, say, delta x bar, so that the coordinates would be x2 bar minus x1 bar. So the rod, we're measuring the rod at rest in x bar t bar. Then by the Lorentz transformations, we might as well just put this on the outside immediately. That factor times x2 bar is x2 minus vt2, and we're subtracting x1 bar, and that's x1 minus vt1, and that gives us let's see. But we want to consider the measurement of length. So we want to do this at a fixed moment in time. So at t2 equals t1, this gives us x2 bar minus x1 bar. Right, the coordinate difference or length in the x bar t bar frame is related to the coordinate length x2 minus x1 in xt. And so the length from the perspective of the observer that sees the rod or object moving in the x direction, we have 1 minus v squared square root times x2 bar minus x1 bar. Right, that's the length contraction expression. So we're seeing that if x2 equals x1, then the clock is in that frame. It's at rest in that frame. If t2 equals t1, then what we're saying is that the rod is in x bar t bar. It's at rest in the x bar t bar frame.